our senior design project is the self-sustaining container home. I'm Emily.
I'm Joseph.
I'm Perry.
And I'm Grace. For background, our self-contained container home is going to have 6 shipping containers. 3 of them are going to be 20 feet and 3 of them are 40 feet. The top level of the house is going to be separate from the bottom level because it's going to be an Airbnb type thing while he uses the bottom level. There will also be a greenhouse on the roof with solar and also solar panels on the roof. There is rainwater collection to support the greenhouse. And then our problem statement is design a rainwater collecting device and alternative power to regulate temperature for a multi-story supported container home.
The first thing we had to do for our project was heat transfer for one of the shipping containers because one of our objectives was to heat and cool this container using alternative energy. Our final results came out to be for cooling the container, we needed a device with 1,500 watts of electrical power, and for heating the container, we needed a device with 3,552 watts of electrical power. This comes out to be about 19 solar panels for the limiting factor of heating the device, which take up 546 square feet of space on the roof.
Afterwards, we moved on to rainwater collection. To calculate the collected rain, we used the formula using average rainfall per month times the conversion factor times the surface area of the roof times efficiency. Below is a table showing the average rainfall per month collected. The average over all the months is 1,743 gallons of rainfall. The average collected per day is 58 gallons. The range of rainfall collected was 40 to 80 gallons, and the tank size was 2,500 gallons because that was the max collected in a month.
And the picture on this slide is showing our ideal idea of what the collection from the roof to the actual tank is going to look like. It's going to be like a Rube Goldberg system. For the greenhouse, we need about 0.3 gallons per square foot of water per day, and that's an average rainwater collected per day is 58 gallons. So that covers that. And then our max size of our greenhouse is going to be 160 square feet. That's just the size of the 20-foot shipping containers that are going to be underneath it. And we're going to be using a mist sprinkler to water the greenhouse as it is most efficient for water use and it provides the largest range of attachments and installation methods. It was also the simplest to use and attached to our water tank.
So because of all the things on the roof and because the Airbnb part is going to have a lot of dead weight, like the appliances and furniture, as well as people living in it, it's going to need a second layer of support between the top and bottom containers. This sublayer will be supported by I-beams, specifically using the wide flange, which are also referred to as W-beams. These beams come in a range of lengths. Most commonly used for recreational uses is the W10 or W12. That just refers to how many feet they are per beam. These follow the ASTM standard A992, and they will need to be galvanized steel due to the moisture that's going to be on them. As you can see in the picture in the top right corner, the wide flange beam does not have fillets, nor does it have angled pieces. It is more for recreational use, while the I-beam like the standard I-beam is used for industrial use. This is a rough model of what the entire structure will look like. As you can see, some things are not completely centered. This was just a very rough idea so we could see it all put together. The tube in the back going to the water tank is a placeholder so we can find the flange of the water collection system beneath the deck. And the greenhouse will need to be more centered as there won't be enough supports to hold the greenhouse up if it's, closer to the edge of the deck like that. You can see that all the solar panels are oriented on the roof and they are in the correct angle to receive the maximum amount of sunlight per day. What you can't see is the container in the back, which is completely supported by I-beams, and it is not on any container at all.